Welcome everyone, thank you for being here, checking in. This is page 433, and we are continuing the lesson on chords and arcs. We're actually proving a conjecture that was made in the previous lesson on some fact about how, like, if the central angles of the circle are the same, then the intercepted arcs must also be the same. Let's prove this conjecture because we specifically have a generic circle. There's nothing too special about it, but we do know this one fact right here. And the first fact that we know is that the arcs, the chords that are there are congruent. So I'm gonna go ahead and highlight those the same. Of course, as always, have some highlight to go along the way. We're gonna prove that the intercepted arc right here, CH, and the intercepted arc right here, RD, that those are congruent arcs. We're gonna do this with some sort of like paragraph proof. We're just gonna write about it, right? We don't need to always rigidly hold to the structure of a flowchart proof or a two-column proof, but a paragraph proof, just gonna talk about it. You know, one thing that we should do is we should construct radii. That seems to be a fact in all of the problems that we've done. There has been some element of constructing radii throughout the diagram. So we're gonna construct OC, OH, OR, OD. They're all congruent because they are radii of a circle, and I'm gonna say it right there. We also know that CH and DR are the same. And so if we know that CH and DR are the same, they actually end up creating congruent triangles. A triangle like right here and a triangle like right here. Those two triangles made up by those sides are going to be congruent by what? It looks like side, side, side matches side, side, side. Okay, we'll say that. By side, side, side. Triangle congruence theorem. Okay, now, what does that mean, right? What does that mean? That means that the central angles that are actually angles in those triangles, the central angle here, COH, and the central angle here, DOR, those angles are congruent. Angle COH and angle, oops, need a congruent symbol, angle DOR. Notice that O is the middle letter. That's how I know I'm talking about the center, O, and these are central angles. That means that those angles are congruent because what happens after a triangle congruent statement? This happens. It's almost like a 1-2 punch. There it is. The triangle congruence leads to CP-CTC. Corresponding parts of congruent triangles are congruent, if you didn't know. Therefore, the intercepted arcs, bam, I brought a note card back for you. The intercepted arcs are congruent. It says that a central angle is equal to the measure of the intercepted arc in the intercepted arc word. So if these central angles create these intercepted arcs, by definition, the arcs have to be equal to each other because the angles are equal or congruent to each other. Therefore, arc CH is congruent to arc DR by definition of and probably also substitution, but you know what, we can let that one go. It doesn't necessarily rigidly need to be said. And something that I've been picking up on my other higher level math classes, like my calculus classes, is we should add a little bit of flair to what we just did. We wrote a proof. So let's put poof in front of the whole thing. This is a proof, and you always finish a proof off in a class. One of the ways is putting a little box down there at the end of it. It's like a little tombstone saying the proof is dead. Thank you, Mr. Halmos. All right, that's it. Thank you for watching this video. More to come in the next couple of pages. Page 434 is next. You are awesome. Like, comment, and subscribe. I will see you in the next video. Bye.